Number 10 says x to the 4th plus x to the 3rd minus 3x squared plus 2. And I'm going to graph it. Okay. So if we look at this graph, how many maxes and mins do we have? 2 mins and 1 max. Okay. So I need to find the min, I need to find the max, I need to find the min. Are they decimals for this one? Ugh, I hate it when they're decimals. Okay. Left arrow, right arrow. I always do 3 decimal places, and the reason I do 3 decimal places is because this is honors, and so I'm just assuming everybody's going to calculus someday. Don't tell me you're not. You don't have to. I'm just assuming. And in calculus, they always do 3, so I'm preparing you early. You're welcome. You're welcome. So all of us future calculus students are just getting prepared early. You're welcome. Okay. Are you guys okay with scrolling? Did we figure that out? Scrolling left and right? Yeah? Okay. So the first minimum, left bound, right bound. The first, that's terrible. The first minimum is negative 1.656. Negative 1.656. Okay, and why did I not write the whole coordinate down? I only need the x value for increasing and decreasing. That's all I wanted. Okay, and then I'll do the other minimum first. And wasn't it nice for those of you who don't have a graphing calculator to do this on Desmos at home? Yes. You just click on it, then it's there. 0.906, but when you get into college or AP Calculus, nah, they don't have those. They don't let you use Desmos. They don't have GoGuardian. So no Desmos. They say get it. No. But you can technically still use GoGuardian. See, GoGuardian is how during a test they make Desmos okay. Is they make it so you can only get on Desmos during the test. So during a test in college, they would say, get out your graphing calculators. You can't get it on a laptop. See? No internet. Yeah. Desmos is so wonderful, but yeah, definitely not in college. All right, second trace, and then for maximum, we're going to use number 4 instead. So the maximum, it's got the E. This happened on the notes, too. What is this trying to say? It's trying to say 0. It's in scientific notation. Your calculator's having a hard time. Because if all of us did this together, we would probably all have different decimals, and some of our calculators might even say 0. So depending on how far left and right you did for your left bound and right bound, all the calculators might be a little different on how they estimated that number. So my calculator is struggling to say 0, but 0 is what it is. And if you look, you can tell the x-coordinate is 0. It's like right there in the middle. Is everyone okay with that? We understood that in the notes when it talked about that. It seems to happen on polynomials more than any other function. That's what I've noticed, polynomials. X or Y, could be either coordinate, but it's not for other numbers, it's specifically for 0. Yeah. Yeah, so it wouldn't be other numbers. It could happen with really big numbers too, but we don't typically do really big numbers when we graph. We often are doing really small numbers that are getting close to 0, and so this is just our calculator struggling. Okay, so we put our stick figure here. What is he doing? Decreasing. Decreases all the way to the minimum, and then what does he do? Increase. He gets to the maximum. It's a positive infinity if you think in terms of up and down, but if you think in terms of left and right, it's a left arrow, and so it's a negative infinity. So positive infinity would have been the y value infinity. Negative infinity is the x value infinity. And since we're doing x values, that's why we wrote negative. Good question. Okay, so increasing up to 0, and then as the stick figure keeps walking, what is he doing? Decreasing, he's going downhill. Okay, hits 0.906, and what is he doing? Increasing, going uphill. Okay, so we have 2 answers for increasing and 2 answers for decreasing. So the first answer for increasing is in between what numbers? Okay, and then the second word increasing is in between what numbers? And infinity, okay. And then why did I use only parentheses? At the moment the stick figure is standing on those points exactly, he's not walking uphill. He's in between. Okay. And then infinity, if I look there, if I was to look at the arrow on the graph, it's actually at a number, not infinity. It's not really happening. Okay. What do I put in between if I'm a fancy mathematician? I put a U, and if I don't put it, it's fine. I'm not going to judge you. Okay. Decreasing. All right. The word decreasing is in between what numbers? Okay. All right, and then the other word decreasing is between what? Okay, 0 and 0.906. Okay, and then what do I put in between? A U. I want you guys to know that you are better at increasing and decreasing intervals than I was when I first started teaching. Yeah, yeah. It's cool, huh? Yes, we're going to do that. Okay. All right. Which one should we go through all the answers for, or should we do more than one?
So just do 13 and 14 because
Okay.
15 and 13
Okay. Okay, perfect. All right. So let's go ahead and take number 13 and let's plug it in to start with. So negative x to the 5th. Are we getting more comfortable typing in those other exponents?
Yes.
Okay. Yeah, that little up button is called a caret. Yeah. And then editing it. Okay. So now this, do you guys see how we're like zoomed out a little bit? If we want to zoom in more just so we can see things, we can hit the window button. I do not do zoom. I don't use the zoom button because it doesn't always zoom the way I want it to. I always hit the window button. And if you look here, we can see that like all this stuff is happening around 2. Everyone see that? 2, 2, 2, 2. So I would maybe make my window to like 4. Everyone see that? Like 4s. So I'm going to do -4, 4, -4, 4. This part, X SCL, Y SCL, it says X scale and Y scale. It's telling you that it's putting the little dashes at the ones. A dash at 1, a dash at 2, a dash at 3, a dash at 4. Yeah, dashes at 1s are fine. It's Y, the little notches on the line. You'll see. Yeah, see the little notches there? Yeah, it's why if you make your graph really big, if you put like 500, the line looks really, really thick because all the little dashes are right next to each other. So if you didn't want the line to look really thick, you could put the dashes like apart, like 50 apart or 100 apart, and then the line wouldn't be thick. But that's why when you make the graph really, really big, the lines look thick all of a sudden. Okay, so now we can see really, really well what's going on. Okay, so it says, where is f of x greater than or equal to 0? I'm going to color coordinate this because I like that. So when it says f of x, what does it really mean? It really means y. Okay, so y, where does y equal 0? Because this says greater than or equal to. So let's start off with equal to 0. Where does y equal 0? They have a special name. Where does y equal 0? Special name. Where does y equal 0? You're going to laugh when I tell you. Yeah, the X-Intercepts. Oh, I actually knew that. Awkward. You knew that. Okay, so y equals 0 at the X-Intercepts, and then y is bigger than 0 above the x-axis or below the x-axis? above. This is where all the positive y values are. So above the x-axis, so this part, so blue is where the answer is for part A. So the first thing we're going to do is we're going to find all those x-intercepts. So the x-intercept here, it looks like it is almost -2, but not quite. It's like a decimal. So what should I do to find the decimal for right there? It's not -2 exactly. Okay, so second trace, number 2. And what should I type in for my left bound and my right bound? 3 and 1. Okay, so I'm going to do -3 and -1. And I'm not going to tell you the answer because you guys are going to do it too. No? Huh? I did that because nobody was picking up their calculators. See how clever I am? It's like I know you guys or something. I had a student say once, but Miss Rice, you're my calculator. All right, Gigi, you win. You got it. -1.895. Marvelous. Okay, let's look for the next one. The next one I think might be 1. It's not 1? Okay. So what should we plug in to find the next one? Uh-huh. What should we look between? 1 and 3? 1 and 2? 0 and 2? Now there's 2 answers between 0 and 2, so will it let us find it? It found that one. Okay, so it found that one over there, but it didn't find that one. Okay, so let's write that one down. 1.789. Okay. And then what about this one right here? I think this one might be 1. Is it 1? Okay. So, but how would we verify that? We can look at the table. Or if we were doing it this way, what could we smush it between? 1.5. Okay. Okay, so 0 and 1.5. Oh, and 1. 1 exactly. That's nice. Okay. All right, we have all 3 x values. So now I have to describe this blue line. So what is the x value of a left arrow? -infinity. Now, the question was about y values, so why am I using x values for my answers? Anyone remember? So we're going to write this above. Ooh. Anytime they ask a where question, they're asking for the x values. Anytime they ask a what question, they're asking for the y values. So if they where is an x value, what is a y value? That's very common. So if they said where is y greater than or equal to 0, they're saying what x values. Okay? All right, so for part A, it makes sense that we're doing x values. The first set of x values are what? Okay. And the -1.895, does that get a bracket or a parenthesis? A bracket, because you can touch it, it equals 0, and the question is asking about what equals 0. So it should be included, okay? How do we do the next set? Okay, 1 to 1.789. And brackets on both sides because we can actually equal those. Those are where y equals 0. And the way the question was phrased, it wants to know where you can equal 0. And put a u in between because we are fancy mathematicians. Wonderful. Okay? Where is f of x negative? So where is y negative? Because that's really what it's asking. Where is y negative?
So one of them is 1.79 to infinity.
Okay, so it's this part beneath the x-axis. And this is infinity. Okay, and then this is the other part. Okay, so the red is my second answer. So the negative part is just the rest of the graph that is underneath the x-axis. So I'm going to say from negative 1.895 to 1. And do I still do brackets? No. Why do I not do brackets? What's happening at these values exactly? No, at these values exactly, what's the y value? 0. Is 0 considered to be a negative number? Is 0 a negative number? No. So since 0 is not considered to be negative, we should not include these answers. Okay? So we are writing the x values that make the y values negative. That's these right here. So it starts at this x value and it ends at that x value. But if we plug in those x values exactly, it's not going to make the y value negative. It's going to make it 0. So it's the y values that are in between those x values, but do not include those x values. Because if I plug in these x's specifically, it's going to give me 0 for y, not a negative number. Okay? So I'll show you what I mean. If I plug in negative 1.895, I rounded, so my calculator is very close to 0. If I plug in negative 1, that's a negative number. If I plug in negative 0.5, that's a negative number. If I plug in 0, that's a negative number. If I plug in 1, that's 0 though. So all the numbers in between are going to give me negatives. But if I plug in those exactly, they don't give me negatives, they give me 0. Does that make sense? Okay. So the other answer is from here to infinity. So it's from 1.789 to infinity. We never actually include infinity because you can't get there. Should we include the 1.789? What do you get if you plug in 1.789? You get 0 if you plug it in. Is 0 a negative number? No. So don't include it. Okay. Next, it says, where does f of x equal 5? So we want to know where the y-coordinate equals 5 exactly. Tell me where the y-coordinate equals 5 exactly. Can you guys tell approximately where it is? Yeah, it's really similar. It's somewhere near negative 2. It's right here, right? This is the answer to C. So here's how, oops, sorry, you couldn't even see it. There it is right there. That's the answer to C. So what we need to do, we're going to have to change our window a little bit because I didn't let the y value go to 5. So I'm going to go ahead and hit the window button. I'm going to take all my values for my window and I'm going to change all of them to 6 so that my graph is big enough so that I can see everything that I want to see. So this is what my window is going to look like now. And what I'm going to have my calculator do, there now I can see everything I need to see. Why are we talking? Did you do this already? Yeah. From the answer key or from your brain? Okay. So we're going to plug in 5 as the y value, and the way that we do that is we hit y equals. We're going to go down to the second one, and we're going to plug in 5. So I want everybody to do that. I've not taught you how to do this before, so we've never done this. Allison, your phone should be away. And then go ahead and hit graph. And so what's happening is this horizontal line is intersecting the function at 5. And what we want to do is we want to find that intersection. So we're going to do second trace intersect, which is option number 5. And if you only have 2 graphs on the screen, then it's really easy to find the intersection. You do not have to move the cursor. The way that the questions work is it says first curve, and you say, yep, I'm on the first curve. And you enter, and then it says second curve, and you say, yep, you just jumped over to the second curve, so that's the second curve. And then you press enter again, and then it says guess, and you say, no, don't use the guess. The guess is always dumb, so you press enter again, and then it gives you the answer. So I always ignore the questions, and I just press enter, enter, enter. And then it spits out the answer really easily. There we go. No, it's good.
Sometimes when I do it though, it just says error or something.
Yeah. Yeah, so these are x values. So I'm just going to say x is approximately negative 2.054. Or if you want to write it like a point, you could say negative 2.054, comma 5. Either one of those answers is fine.
What do you do after you go to that?
You do second trace number 5, and then you press enter, enter, enter. Did you do second trace number 5? All right. We're going to go ahead and move on just because I want to make sure we can get the rest of our notes done. If we have time to go back to 14, we will. Okay. Let me go ahead and hand out the note. Okay. So it says a water balloon is catapulted into the air so that its height in meters after t seconds is modeled by the equation, and then it gives you the equation. Sketch the path of the water balloon on a set of axes before you begin answering the questions. So let's go ahead and draw what this looks like. So we would have like a little person standing here. I'm very good at drawing people. I hope you're impressed. And they would have like the water balloon, and they're catapulting it. It goes like up in the air, and then it comes back down, like hits, and then it like splats. See all the water splatting? There we go. It's marvelous. Okay. So this over here is where it hits the ground. This is its maximum height. This right here is where it is released. This would be our x-axis. This is our y-axis. In the problem, they don't use x and y. They use t, and they use h. And the x-axis stands for time, and the y-axis stands for height. And so we're going to make sure that we keep that in mind as we do the problems, that the input has to do with time and the output has to do with height, because it's going to help us figure out when we solve the questions on our calculator, like which one we're going to do. RJ, will you put the Chromebook away? Thank you. All right. Okay, so what we're going to do first is we're going to plug this problem in, and then we're going to figure out what our window needs to be so that we can see all the important stuff. So before I even do that, since we just messed with the window, I'm going to type second plus 712 just to get everything out of the calculator. So second plus 712, I want to start from scratch with the fresh calculator settings. And then I'm going to type in negative 4.9 x squared plus 27x plus 2.4. So I'm just typing in the equation. And then you can graph it now if you want to. It's usually not going to graph everything, or not in a way you can see it. With story problems, we usually have to change the window before we can see what we want. So from here, I'm going to hit second graph. I always use the table to help me figure out what my window should be. So you can see if what you're plugging in is time, and this is time. It's always good to know what your units are. So this is time in seconds. Yeah.
So in the graph, do we like change it to T instead of X?
Nope. You're still going to use X and Y. Your calculator always does X and Y. So our time is in seconds, and then in the problem they said meters. The height is in meters. So time is in seconds, height is in meters. You can see time is 0, height is 2.4. Then it goes up, it goes up, it goes up, hits the highest point, and then it starts coming down. And then down here we have a negative height. And so we can see that the very highest height that we are able to see is about 40. The highest X values that we really need is about 6. So if we look at our window, the highest X values that we have normally are 10, so I'm going to leave this alone. But the highest Y values we had were about 40. I need to go bigger than 10 because 40 is not what my calculator goes up to. And I usually like to go a little bit bigger than what the calculator did. So I'm not going to do 40 because that was pretty close to the highest number they had. I'll do like 50 just so I know that I went plenty big enough. So Y max I'm changing to 50 because my Y's were 39 point something. Now I'll go ahead and hit graph and I should be able to see everything. Now if you don't like that this line got thicker, the only reason it got thick is because if you look at the window, the scale is by ones. If you want it to be less thick, change the scale to go by tens and then hit the graph button, and now it's going by 10, so it's not thick anymore. All right? Okay, so here's our graph. This problem says, what is the initial height of the balloon? Wait.
No, no.
What is the initial height of the balloon?
What is Y?
Yeah. So if they're asking a what is the height question, they want to know a Y value, which means we should know what the X value is. Meters. So if they say initial height, then what X value should we use? 0. Okay? So anytime we want to plug in an X value, I'm always going to use second trace number 1. Number 1 allows you to put in any X value that you want. So you can plug in 0, which means that we're finding the Y-intercept. All right, so plug in 0, and then if we do that, what do we get? 2.4. You can use the table. That's fine, yeah. Okay, next question, how high? How high is the balloon after 1 second? So if it says how high, it's asking for a height. Is it asking for a Y or an X? It's asking for a Y. That means it gave you an X. What X did it give you? 1. Plug in 1. So I'm going to do second trace number 1. And plug in 1. You can use the table. Yeah. 24.5. Okay. All right, this one says for how long? If it says for how long, that's X because that's time. Okay, so then that means they gave you a Y value. Which Y value did they give you?
Greater than or equals? No.
Yeah, you're right.
Or greater than or equals to
30. Okay, so let's draw a picture of this. So the water balloon goes up in the air and it comes down, right? So what's going to happen is it's going to hit 30, it's going to go up in the air, and then it's going to come back down to 30. So what they want to know is like how much time passed. So there's going to be 2 answers here, and then we're going to have to see how much time happened in between them. Does that make sense? Okay, so where can we plug in a Y value? Where can we plug in a Y value? We just did it on that last worksheet. We plugged in the Y value equals 5. On the Y equals, yeah, we're going to plot it like a horizontal line. We're going to plug in Y equals 30. Okay, so I'm going to write Y2 equals 30. We're going to do it in the Y equals. We're going to graph it. Okay, and once we graph it, now we have a horizontal line at 30. Once we graph it, second trace number 5. Okay, so now once I do that, for the first intersection, I'm just going to press enter, enter, enter. And that's going to give me the first answer. So I'm going to write on my notes, second trace number 5. I'm writing all of these things down because these are my notes. I do not have to do this on the assignment. I'm doing it on my notes so that if I brain fart later, my notes are good. Okay? All right. Okay, so my first intersection is this. I'm going to write all the decimals because in math, we never round in the middle of a problem. Right? You guys know that? We never round in the middle of a problem. We're in the middle of the problem right now. Okay, so there's the first intersection. Now, here's where we're going to find the second intersection. So this time we actually have to do something more. So we're going to do second trace number 5. And this time we just have to move the cursor so that it's closer to the second intersection than it is the first. Because if I press enter, enter, enter again, it's just going to keep finding the first one over and over and over again. Because that's the way that it works. It just finds the ones that it's closest to. So if I press the right arrow down, and I get the cursor closer to the second intersection, it does not have to be on top of it. You do not have to be squinting and getting your face really close to the calculator screen and trying to be perfectly on top of it. It doesn't matter. Just get closer to that one, and then once it's closer, press enter, enter, enter. And then it will find the second one. Does that make sense? Okay. So 4, I'm going to write down all those decimals because I'm not going to round yet. 4.1543641. Okay, there's all my decimals. So it says it started being at 30 feet high at 1.35584 seconds. It stopped being 30 meters high at 4.1543641 seconds. So if we want to know how long it was over that, then we got to subtract them. Okay, so the reason we wrote down all those decimals is because we want to be able to subtract these numbers and still have our answer accurate to 3 decimal places. That's why we didn't round yet. And now you can go ahead and round to 3 decimal places. Okay. All right, what is the maximum height? Okay, so what is the maximum height? Is that a Y or an X? Y, okay. And did they give us an X to plug in? No, they didn't give us an X to plug in. So somehow we are going to have to know where to look on the graph. We're going to find the Y coordinate, and somehow we know where to look on the graph. Where do we look? The Y coordinate, the maximum height of the balloon. Yeah, we look at the top. We look at the max. Okay. So second trace, max. Second trace number 4. Second trace number 4. Okay. Second trace number 4. Isn't it fun to get the answers this easily? Are you guys aware of how much math we've done already? It's a bunch of math. But you have these neat little notes that tell you what to type in. And we're going to use the Y coordinate. Okay. Okay, the next question, when? When will the balloon burst as it hits the ground? When? Okay, so we're finding an X. And if it's hitting the ground... It's a 0. It's an X-intercept. It's a 0. Okay, so we knew how to do that. Can you guys tell where it is? 1, 2, 3, 4, 5. So it's between 5 and 6. Okay, so we're going to do So we're going to do second trace number 2. Okay. Second trace number 2. And what are we going to use for our left bound and right bound?
Wait.
5 and 6.
I tried to figure out how to do that. Second trace number 2, you said?
Yep.
You just put the 4, 5, and 6. You have to make sure
Okay. The next question says when? When is the balloon 27 meters high? So X, and did they give you a Y?
yes,
Y is 27. Okay. So where do we plug in a Y value? In the Y equals. So we're going to say, we're going to put in 27 for our Y2. We're going to graph 27. So I'm going to take the 30 out. I'm going to put a 27 in instead. And second trace number 5. Okay. And then what do I do? Yeah, enter, 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 because we're looking for the first one, so I don't even have to move it first. Enter, enter, enter. Okay, so my first answer, 1.152. So this one I don't have to worry about rounding because these are just the answers. It doesn't say how long is it 27 meters high. It just says when. I just got to say when. So,
question
yeah.
about number 3.
Uh-huh.
So, why would it be like y is greater than 30 or something like that? Because it said.
Because so the only reason I didn't do that is because that's not my final answer. I just wrote that down to help me know what to plug in.
Okay, so you plug it in every time, even if it's asking for what's over there.
Yeah, because I used my brain to know that that's what I had to do. I didn't plug that in my calculator that way. The calculator was just to plug in 30 so I could find those specific points. And then my brain told me now I have to use the whole top piece and get those answers and subtract them. And then this one is telling me, okay, I'm plugging in 27, but I'm only using the exact answers. So my brain is helping me figure out the rest. But my final answer, in fact, we haven't even written our final answers yet. We're going to go back and write final answers for all these in 1 second. Yeah. Okay, and then what the other answer, we're going to do second trace, number 5, and we got to move it over so it's a little bit closer to the next one, and then press enter, enter, enter. 4.358. Okay, so anytime you have story problems, we really should be writing story answers. So move your calculator off to the side, stretch your fingers out. We're about to write some sentences. You guys ready? Stretch, and stretch, and stretch, and stretch. Are you laughing at me? I don't write that often. No. No, but just little bits at a time. Now I'm going to write a whole sentence. It's going to be very hard. Okay. All right, what is the initial height of the balloon? The initial height of the balloon is?
I love writing sentences.
Good. You're going to get a chance today. Uh, 2.4 meters. Look at that. I put a capital in the beginning. I put a period at the end. I didn't do any abbreviations. My English teacher would be so proud. A++. Miss McEnany. Miss you, girl. McEnany. It's the name of a human being, so let's not mock. Rude. She got divorced my senior year, though, so I don't know what she goes by now. All right. How high is the balloon after 1 second? After 1 second. After 1 second, comma. The balloon is.
See, math is not my.
You can't write one. You have to do like in proper sentences. It's one.
I think it's fine.
I remember that from my English teacher.
I don't believe.
After 1 second, the balloon is 24.5 meters
Be a blur.
high.
Sentence diagrams.
Good morning, Rocket. Any band members, cheerleaders, or drill team?
All right. The next one. For how long is the balloon more than 30 meters high? The balloon is more than. I do think there's a rule though. If the number is less than 10, then you write it out in the word. But if it's bigger than 10, then you write the number.
I just remember Cynthia Bloom said no numbers. You have to write the word.
No, there is some rule. I know there's some rule about, but some of them you actually write as numbers.
Do you write anything above 10?
Is it? Yeah, it is above 10. Okay. The balloon is more than 30 meters high. For 2.799 seconds. You guys, I need you to ask your English teachers if, when we have a decimal, if we're supposed to write that out as words.
No.
You guys just answer no because you don't want to. You would say 2 and
Can I Google it?
wait, 10th, 100th, 1000th, 799 thousandths.
Can I Google it?
No, we're fine. We'll just keep going. Okay. The maximum height of the balloon is. Are you guys all writing your sentences? The maximum. Is anybody else getting like a cramp in their hand? I think I have carpal tunnel.
I choose to write essay twice.
No, the question said what is.
Anybody who has this, our hands are conditioned, bro.
When will the balloon burst as it hits the ground? The balloon will burst. Whew. That was the funnest part.
The more you write it, the weirder.
Most funnest? Yeah.
That's such a weird word.
Yeah, I kept wanting to write Balon and put 1 0 1 0.
No, it's just balloon. Why is it like that?
Who knows?
They're so like some words are so weird.
I can write a six down and then I can question myself.
You can't say make racist jokes really loud and then not explain yourself. Everybody's concerned now. And now there's a whole rumor that started about Angela the racist. And I'm recording, so now it's going to go on the interwebs. That's true. See something, say something. So now it's going to go, now it's going to be all official. All right. How are the sentences coming along? All right. When you are done with your sentences, go ahead and turn the page.
I'd say this when you let us on our intro, like, oh my god.
Well, you're going to have these notes. There's two situations.
When
There's
you're holding my hand, I'm doing great and I understand. And then the second I'm on my own, it's just like, dang, I can't do it.
there's two situations that we can have. There's what this is called projectile motion.
Wait, what's projectile?
That's this projectile motion because this is projectile motion.
What's the other situation?
The other situation is volume of a box.
Are we going to do that together? Okay, wait. Projectile motion.
All right, go ahead and flip the page. So we just did projectile motion. That was a quadratic. Next, we are going to do. Yes. Next, we are doing volume of a box, and so this is a cubic. Yep. These problems are very common on the EOC.
So it's just volume.
Yep, they also seem to be pretty common on the ACT, SAT. Like I've seen this particular phrasing of the problems, which is why we're going over it.
When do you think that this
It's a great question. I'll answer later. I'm sorry, I don't know off the top of my head. All right. It says an open box. Are you guys ready? Are we ready? An open box with a rectangular base is to be made from a piece of cardstock that measures 8 centimeters by 12 centimeters. And the way they make this box is they cut out a square from each corner and they turn up the sides. Okay, so I'm going to show you guys. So let's draw the cardstock and we're going to label it. And I want you to label it exactly the way that I label it, okay? Cardstock is the really thick paper.
I love writing.
Okay, so here is the piece of cardstock. This is cardstock. See? It's really... It's cardstock. You can hear it? That's what cardstock sounds like. Okay, cardstock. All right. This is not to scale. This is a bigger piece of cardstock, but you're fine. Yeah, it's a rectangle. All right? Yeah, not to scale. Not to scale. Okay. So 8 centimeters by 12 centimeters if you measure on the outside. Okay? 8, 12. Everyone see it? Okay. Now, they are saying if you take this and you cut out the corners. Everyone see that? We cut out the corners. Okay? So what we're going to do is we're going to adjust our drawing. We're going to cut out the corners. And then we're going to kind of shade them in. We're going to show, oh, yep, I cut out those corners. That was terrible.
That was so good.
That was really bad. All the dads of America would be so proud. Okay, so now, once you have cut out the corners, listen carefully. You guys listening? Once you cut out the corners, we fold this flap. Do you guys see how I folded it? And then, are we all listening? And then we fold this flap. And then we fold this flap. Do you see? And then we fold this flap. And now we have a box. See how if you taped it, you'd have a little box without a lid? Everyone see that? Okay, but pay attention. This is a very common math problem. You will be asked to do this over and over and over again, okay? Are we listening? On all different types of tests. So they cut out the corners, and when you cut out the corners the same way, you can fold the flaps. You can make a box out of it. Everyone see how that happened? Okay? So let's go ahead and draw the folds. So we're going to say I folded it right here. 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 Okay, so now they want the dimensions of the box. So they want to know what the length is. They want to know what the width is. They want to know what the height is. Okay, so the original length of the box was 12. But we cut off an inch and we cut off an inch. Or not an inch, we cut off a centimeter. We cut off a centimeter, we cut off a centimeter. So it's no longer 12. What is it now?
11.
Not 11. It's 10. Okay? I need you guys are talking and you think it's not a big deal, but you're actually being very rude. Okay? So 12 was our length. We cut off a centimeter on one side. We cut off a centimeter on the other side. What's the new length? 10. Okay? So what I'm going to do is I'm going to write it exactly like this because it's going to help us when we have a variable in the future. I'm going to write 12 minus 1 equals 10. Okay? My width when I started was 8. I minused a centimeter, and I get 6. Okay, but I'm going to write it like this. I'm going to say 8 minus 1 equals 6. Okay? Goodness gracious.
At this time, all varsity football players report to
All right. Now, look at this. Listen carefully. Shh. If you take this and you fold it, what's the height going to be?
It's gonna be less than it was before. Or no, it's gonna be.
What's the height? It's going to be 1 centimeter. Whatever the size of the square is, when you fold these, that's what creates the height. So if the square was 1 and I fold it, now it's a height of 1 centimeter. Okay? So we're going to say the height is 1. Okay, so what's the formula for volume of a box?
Length times width times height.
Okay, so we say volume is length times width times height. So we're going to do 10 times 6 times 1. And what do? We get 60 centimeters cubed because it's volume. Okay, we're done. All right, let's do it again. This time they say you start with the same thing, 8 centimeters by 12 centimeters. But this time you are cutting a 2 centimeter square out of each corner. Are you all done? I'm not going to be able to answer it. I'm not going to be able to answer it for a while. Let me get through this, so skip it for now. And then I'll come over and help you when I can. All right, so we're cutting out a bigger square. So draw basically the same picture, but cut out a bigger square. So we've got the length, the width, the height. And we're going to picture this again, okay? So we have the overall length is 12 centimeters. We cut off 2 centimeters. We cut off 2 centimeters. And so what's the new length? 8. So I'm going to say 12, take away 2, and the new length is 8, okay? The width was 8 centimeters. I cut off 2, and what's the new width? 4. Okay, so I'm going to say 8, take away 2, my new width is 4, okay? The square that we cut out was a 2 by 2 square. I take this and I fold this, and this is what creates the height. So the height is 2. And so my volume is 8 times length, or is length times width times height. And so what is it? 64 centimeters cubed. So apparently cutting out a bigger square actually makes a bigger box, which is interesting. Yeah. Okay. All right, so now they're saying, let's take this problem and let's make it a Math 3 problem, because it's not a Math 3 problem if you actually know the numbers. Okay? So now let's draw the picture. We're going to cut out the squares, but this time we don't know the numbers. Okay, so we got 12, we've got 8, we got length, width, height. Okay, so this time, instead of having a 1 by 1 square, instead of having a 2 by 2 square, we have an x by x square. Yes? Because I'm bad at drawing. You're cutting out a square, but your box is not square. I'm answering your question. Your box is not square.
I don't know why, but I thought.
You're cutting out squares to create the box, but they're not claiming that the box is square. The box is rectangular. Does that make sense?
I'm just not interested in drawing anymore. Because it looks like a
my picture. My pictures are not very good.
Yeah, that's what I'm saying.
Yeah, I'm sloppy. Yeah. Generally speaking, drawings are never drawn to scale, and I take that to an extreme where I'm just like, I very sloppily draw things now. Yeah. No.
I'm just trying to figure out where we are.
We're in algebra still.
We're just, so we're in what still, you said?
Algebra.
Well, yeah, okay.
Okay. So 12 was the original length, minus x minus x. And if we had 12 minus x minus x,
Do we not know the,
nope, we don't know it. I'm going to call that 12 minus 2x. Okay. Now, the width originally was 8, but I cut off a square on one side and I cut off a square on the other side, so I'm going to say that's 8 minus x minus x, so that's 8 minus 2x. The nice thing about these problems is they always have the minus x, and so it's always the length minus 2x, the width minus 2x. They always work out that way. And then the height is always created from the square that was cut out, and so the height is always just x. Yeah.
Will it ever be a different thing? It's like 2x's?
No, because this problem is always set up the same way. Yeah. So the volume as a function in terms of x is length times width times height. No, we're done because we're not going to FOIL that. We're going to leave it just like this because, yeah, because if we FOIL it, we could make a mistake, and our calculator can handle this just fine. So let's keep in mind, just like the previous page, we knew that the x value represented time and the y value represented height. Let's make sure we keep in mind what this input, what this x value represents, and then what the output, what the y value represents. So we know that the input, the x value, represents the size of the square, the size of the cut out square. So whatever you plug in, that's the size of the cutout square. And then you can plug it into the individual pieces to get your dimensions pretty easily. And then once you plug in all the x's, it spits out what?
Y.
The y. And what is the y? Sorry, my nose is running. It's not on my face. That's cool. The y value's over here. What is this? Volume. The y, which is the volume. Volume of the box. Okay. All right, so let's grab our calculators. I'm going to do second plus 712. I'm going to clear my calculator. And now I'm going to plug this into the y equals. So 12 minus 2x, 8 minus 2x, and then just x. So 12 minus 2x, 8 minus 2x, and then just x. Okay. And now it says, for the first question, it says, what is the volume? So are we finding a y or an x? We're finding a y, which means they gave us an x. What x did they give us? X is 1.25. So how do we plug in an x if they gave us, if we want to find a y? How do we plug in an x? Yeah.
You do
Second trace. Second trace, not 0.
second trace number 5?
Number 1. Second trace number 1. Oh, sorry, we haven't graphed this yet. Sorry, I was jumping the gun. Okay. Before we find any answers, we have to hit the graph button. We're going to realize that we can't see hardly anything. And so let's do second graph. Let's figure out how big our screen should be. Okay. If you guys look at this, we can see that the x coordinate is how big the squares can be that we're cutting out. The y coordinate is the volumes. And it looks like the biggest volume that we have before the volumes become negative is 64. So I'm going to hit my window button. I need to choose a y that's bigger than 64. And probably a lot bigger than 64. 80, maybe 75, something like that. Yeah, just so I wouldn't do 65. That's a little bit too close to 64. I'd go maybe 10 bigger. All right. So this is the part that we're looking at right here. If you don't like how thick that line is, you can change it and tell the y's to go by 10s or something, and then it will look a little bit more normal. Okay. So now let's go back to number 10. What is the volume if you're cutting out a 1.25 centimeter square? So now we're going to say second trace, number 1, plug in 1.25. Okay, 1.25, 65.313. Okay. The next one is a very similar problem. What is the volume if a 2.3 centimeter square is cut out? So now I'm going to plug in 2.3, and you'll notice since we're doing all these questions in a row, you actually don't have to push second trace number 1 again. You can actually just keep pressing the numbers in. 57.868. What is the volume if a 4.5 centimeter square is cut out? So again, we're finding a y value, and they gave us the x value is 4.5. Okay. Does this answer make sense? Yeah, negative 13.5. No. So, does 4.5 make sense? Can I cut out a 4.5 inch square if my width is 8? No. Okay. So does this make sense? So we're going to say no, we can't. This is what we call an extraneous solution. Like mathematically you can solve for it, but it does not make sense, like in the context of the problem. So does this make sense? I would say no. You cannot cut out a 4.5 centimeter square. Okay. Yeah. A 4.5 centimeter square. The volume of a 1.25 centimeter square is cut out is 65.313 centimeters cubed. Abby, the notes are up here, and I think they're in the middle. I think so. I don't know. I put piles everywhere. Wait. Pull out the middle one. Show me the front. Yes, that's right.
Dang it.
Sentences are so fun. When you're done with your sentences, go ahead and flip the paper over. I know, this is why I don't like doing non-flipped.
Wait.
Yeah.
So why did you do it now?
Because the quiz threw us off.
So are we having them sign the worksheet?
No. Just this. Yeah, just the worksheet. right, we're not done yet, folks. Flip the paper. For what size square? For what size square is the volume the largest? Where do you guys think the volume is the largest? Can you see it on there?
Does it go to infinity?
Well, it goes to a negative volume first, so anything over here we're going to ignore. So we can only look over here. That was a good question. So for what size square is the volume the largest? It's the maximum. So the largest volume is going to be up here because we ignored this whole part of the graph. We have to ignore everything after the graph turns negative. So the only part of the graph that's valid is this part. So we're going to look at the maximum. And when it says for what size square, what answer are we looking for? What size square? Is that the x or the y? That's the x. And volume is the largest, that's the maximum. Okay, so let's do second trace number 4.
This is where you have to do enter.
No,
Move it till you get close to it first. Then
nope, you got to do left and right bound. Yep.
Wait, what?
So the intersect is when you do the second trace number 5.
You can tell with this one that you don't do that because it asks you left bound, which is, yeah, it asks you left bound, which is the same thing that it asks you when you do second trace 0. When you find the X-intercepts, that one asks you left bound and right bound also. So you kind of know because the calculator prompts you the same way. So the maximum is 1.569. 67,604. All right, are you guys ready for a cool trick? So we need the dimensions, length, width, height. We know the length is 12 minus 2x, the width is 8 minus 2x, the height is just x, so we know the height is 1.569. Okay, so when you have something in your calculator and it looks like this, your calculator stores these numbers as x and y. It stores them for you periodically. Like every time you do something in the calculator, it stores it just for a second. So what we're going to do is we're going to quit out of this and we're going to use that stored decimal so we don't have to write down all these decimals. Okay? So if this is on your screen, we're going to hit second, quit. And now if you hit the X button and press enter, it just put that decimal on the screen for you. See how that decimal matches? Yeah. Because we're going to find the length. Because it says the next question is, what are the dimensions? So 12 minus 2x, there's the length. Eight minus 2x, there's the width. It plugs it in for you, and you have the accuracy of plugging in an unrounded decimal without you having to type it in. I know. These calculators are so cool. Okay. Now, if you wanted... All right. Well, look at Google Classroom. I will tell you which problems in the packet I'm about to hand out you can actually do. Okay? I know. Wild, right? Leave the characteristics assignments behind.
We'll be here Monday. We turn our notes to do?
Yeah. Leave the characteristics stuff behind. Look at Google Classroom because I'll tell you which questions to do.
the notes and the sheet. Like the notes and
Yeah. every day. I've had curly hair every day.
But how do you usually wear your hair?
I usually wear it up,
I used
But
to
it's-
wear mine like that.
but it's curly every day.
But then I was like, I just like my curls. So then I just started. Somebody left their cut, they not doing their homework. How high did the balloon? How high is the balloon not to say? Question: do we have to have like 8 reading and 8 math? Well, can you go down because we only had 2 days.
Can you mark me present? I gotta go to the field.
We're all gonna go to the field.
Yeah, but I gotta go right now.
Why?
Part of the team.
What team?
Soccer.
The-
They told us to finger first and then we go there.
Okay. Yeah, that's fine.
So they told us not to wait to go as a whole class.
As a team?
Oh, we only had 2 days already. It's a real name already yesterday, and then we have to check out. Please. I did 2 reading. I did all but 1 math. Wow.
You want me to not plug it in until Monday?
Yeah, yeah, but I don't know how to do this new math that I got either. You're gonna give us till Monday? Yeah. Good, because I need to. Well, I work Saturday and Sunday. Dang! Do it when you get home from work. I don't get off until like 10. We'll do it before. Yeah, do it before. Exactly. I have to sleep before I go to work. I gotta go into work at. I'm tired in the morning.
Thank you.
I gotta go to work.
Thank you.
Saturday, she like put me on like 9 to 10. Yeah. Kids are down, and plus I work at food. Oh, yeah.
Hang on to it. And hang on to it. We're not sitting together. You guys are sitting. Somebody has to show me where to go because I don't even know how to get out there. You can go on the way. All right, we're heading to the stadium. The stadium. Sorry, I didn't grade the check for understanding yesterday. I got caught up and forgot.